Hey everyone, last one for the holidays. Hope you're all alright. Reach out if you need anything. Um, so this chapter will be, or this exercise will be quite short, I think. Um, so we're looking at the quadratic formula, or the general quadratic formula. Now when we head back to school, we're going to look at this a little bit further. But basically when we have a quadratic equation, so we've got ax squared plus bx plus c is equal to 0. For example, that could be x squared plus 3x plus 2 equal to 0. Now, to find the x values that satisfy this, normally we'd just factorize. So if we factorize, it would get something like x plus 2, x plus 1 in brackets is equal to 0. Using our regular a times b is equal to 2, a plus b is equal to 3 technique, which we've done in the past. Alright, so this is what we have been doing. But what we can actually do, there's this formula that works basically 100% of the time. So the formula is, let's write it out in a different color, is, actually before we do that, so the value here is x is equal to minus 2 and x is equal to minus 1. So there are two x values. Cool. And also just to remind you, if we were to graph this, that would be the intercept. Minus 2 and minus 1 here. And it looks something like that. Anyway. Cool. So we actually have this formula which will get us these x values here 100% of the time. Now the formula is x is equal to minus b plus or minus the square root of b squared minus 4ac on 2a. It looks pretty gross. It is pretty gross, but I guarantee you by the end of the year you'll have this memorized. Alright, so let's use this formula on this equation here. Remember that we have our a is just the coefficient of x squared, our b is the coefficient of 3, and our c is the coefficient of 2. Okay, so we have x is equal to minus b, and remember b is 3, so it's minus 3, plus or minus square root and b squared, so that's 3 squared, minus 4a, so a is 1, and then c is 2. All divided by 2 times a, and remember a is 1 here. So we get minus 3 plus or minus, well, what's the square root, what's 3 squared? It's 9. And what's 4 times 1 times 2? It's 8. So minus 8 over 2. And that'll give us minus 3 plus or minus the square root of 1 over 2, which is minus 3 plus or minus 1 over 2. So it's got two scenarios here. So we've got x is equal to minus 3 plus 1 on 2, and x is equal to minus 3 minus 1 on 2, because they have a plus and minus here. So minus 3 plus 1 is minus 2 on 2, which is minus 1. Minus 3 minus 1 is minus 4 on 2, which is minus 2. And we can have a look, and we'll see that, well, x is minus 2 up here, x is equal to minus 1. We've got x is equal to minus 2, x is equal to minus 1. So this quadratic formula is extremely useful. So the main advantage is it always works. A disadvantage is that it can take longer. So if we look at our quadratic equation up here, this isn't super complicated. It might take a little bit of time to solve this quadratic equation at the moment, but I guarantee you in a year's time you'll be able to do it in a couple seconds. Whereas this quadratic formula requires 1, 2, 3, 4 lines of working, and then plus this extra working here to the right hand side, so it can take a lot longer. So it is a bit of a trade-off, but if you're lazy, it always works. It's very, very useful. Now, something to note, even though it always works, sometimes the quadratic equations don't have solutions. Now we'll look at that next exercise, so don't worry too much, but basically we're going to look at what's under here, what's under the square root, because obviously you can't have a square root. You can't have square root of -1. That doesn't work. So if b squared minus 4ac, i.e. what's under the square root, is less than 0, we're going to have a bad time. But we'll go into this later on, so don't worry about it now. Okay, so let's do question 2a. So we want to, before we actually get into using the quadratic equation, just a quick recap of simplifying fractions. This is why we did a bit of work earlier on in the term. Now, if we look at this, the numerator, we can take out the common factor of 2. Keep the denominator the same, and you'll see that these 2's will cancel. So you'll just be left with 1 over the square root of 5. So we took out the common factor of 2, and then we cancelled it with the denominator. So we'll do all of question 2 for homework. Now the next question we'll do is question 3a. So we've got the quadratic equation x squared plus 6x is equal to 4. So we want to make it look like ax squared plus bx plus c is equal to 0. That is, we want 0 here on the right hand side. So what we can do is we can take 4 on both sides, so we'll get x squared plus 6x minus 4 is equal to 0. So now we have it in this form here, which means we can use our quadratic equation. And remember, it's x is equal to minus b plus or minus the square root of b squared minus 4ac on 2a. So in this instance, what's our a? Our a is 1, because it's just 1 here. Our b is 6, and our c is equal to minus 4. So let's just chuck it in this quadratic equation. We've got x is equal to minus b, so minus 6, plus or minus square root of b squared, so 6 squared, minus 4ac over 2a. So it'll give us minus 6 plus or minus 6 squared is 36. minus 4 times 1 times minus 4, we get positive 16 over 2. So you get minus 6 plus or minus square root of 52 over 2. Now the square root of 52, well, that's equal to the square root of 26 times 2, which is equal to the square root of 13 times 2 times 2, which is equal to the 13 times the square root of 4. Sorry, the square root of 13 times 4. Now what you can do is you can actually just split it up like this. If that confuses you, have a look back at your laws. And the square root of 4 is just 2. So you get 2 square root of 13. Now, you might be able to do this in your calculator. Have a look. So we can simplify this a little bit more. So the square root of 52 will become 2 square root 13 over 2. Now, what we'll do is we're going to simplify it like we did up here in 2a. So we can see that 2 is a common factor here on the numerator. So we'll take 2 out. And we'll get minus 3 plus or minus the square root of 13 on 2. These 2's will cancel, and you'll just be left with minus 3 plus or minus the square root of 13. So our two answers are x is equal to minus 3 plus the square root of 13, and x is equal to minus 3 minus the square root of 13. And you can just leave it like that, because remember, 13, the square root of 13 is a surd or an irrational number, whatever you want to call it, and it can't be simplified anymore. So just to recap what we're actually doing, we're just using this formula here, and we're just substituting numbers into that formula. This part here, that's just testing your ability to plus and minus and to simplify things, to factorize and simplify. So these are the fundamental skills that we're going to keep working on and make sure we're all over. But all we're doing is effectively just subbing numbers into a formula. All right, we'll do a couple more. Let's do 3b. So 3b, we have x squared minus 7x minus 3 is equal to 0. So it's already in this form, ax, the general form, ax squared plus bx plus c. So we have a is equal to 1, b is equal to minus 7, and c is equal to minus 3. So we got x is equal to minus b, so it's minus minus 7, plus or minus 7 squared, minus 4 times a, and then times c, over 2a. So it sounds confusing, but you're just plugging numbers into a calculator or to a formula. So minus minus 7, that'll become 7, plus or minus, now minus 7 squared is equal to 49. Minus 4 times 1 times minus 3 will give us positive 12. All over 2. Which will go 7 plus or minus square root of 61 on 2. Now, I think that's as simple as it can get. If not, prove me wrong. So x is equal to 7 plus the square root of 61 on 2, and x is equal to 7 minus the square root of 61 1, 2. Why I think it's as simple as it can get is because we have 2 on the bottom, which is an even number, but 7 is odd. So we're probably not going to get any simpler. Yeah. Alright, let's do a third and final example. Let's do 3c. So we'll have 2x squared minus 5x plus 2 is equal to 0. Now in the past, factorizing these has been really hard. Or I find it pretty hard actually, because it's got a 2 in front of the x squared. It's kind of fine when it's just a 1. It's a little bit easier to factorize, but when we have a 2, it makes it a whole lot more complicated. So in the last, I don't know how many years I've been doing maths, I've very rarely factorized equations myself when they have a number bigger than 1 in front of x squared. I normally just use this quadratic formula we're using. Okay, so again, we have our a is equal to 2, our b is equal to minus 5, and our c is equal to 2. And let's just plug it into our formula. X is equal to minus b, so it's minus 5 plus or minus the square root of b squared, so minus 5 squared, minus 4 times a times c over 2a. So minus 5 is positive 5, plus or minus the square root of, or minus 5 squared is 25, minus 4 times 2 times 2, which is minus 16, over 2 times 2, which is 4. So we get 5 plus or minus the square root of 25 minus 16, which is 9, over 4. Now we know the square root of 9 is equal to the square root of 3 squared, so it's equal to 3, because those will cancel out. So we get 5 plus or minus 3 on 4. So our first x is 5 plus 3 on 4, and our second x is 5 minus 3 on 4. So you'll get 8 on 4, which is 2. So your first x is 2, and your second x is 5 minus 3 on, which is 2, on 4. So x is equal to 1/2. Alright, I think that's it. All of the questions we did were basically the same. The only question that was slightly different was question 2, which is simplifying stuff. And that's just really testing your algebra skills more than anything. So let's revisit our success criteria and learning intention. Hopefully you can use the quadratic formula after doing your homework to solve quadratic equations. And if we're given a general quadratic equation, we can use the general quadratic formula to solve it. Sweet, all good. I'll post the homework questions on that Google Doc again. Cool, catch you later.